students, before start the nth differentiation of a products. So let us see one interesting problem on nth differentiation. So that is prove that nth differentiation of tan inverse of x by a is equal to minus 1 to n minus 1 into n minus 1 factorial by r to the n into sin n theta. The corresponding values of r and theta is r is square root of x square plus a square and theta is tan inverse of a by x. And also by using that we need to find the nth differentiation of tan inverse of x. Nth differentiation of tan inverse of x. Yes, let us take this function tan inverse of x by is y. So let y is equal to, so let us take y is equal to, it is tan inverse of x by a. So differentiate this with respect to x. Differentiate with respect to x. Differentiation of y is y1. y1 is equal to differentiation of tan inverse of x is 1 by 1 plus x square. So differentiation of tan inverse of x by a is 1 by, or it is it is 1 by x by a whole square into differentiation of 1 by a is x by a is a. So that is its differentiation is 1 by 1 plus x by a whole square. Again differentiation of x by a is 1 by a. Or if you know its formula directly, you can write it directly, no problem. So then it is this is 1 by, take it is x square by a square, and you take a square is the LCM, a square plus x square divided by a square. So this into 1 by a. So now one of this a cancels. So now y1 is equal to, so that y1 is equal to, so ಹೇಗೆ ಬರೆಯಬಹುದು y1 ಅಂದ್ರೆ, so now y1 is equal to, this a comes to numerator, it is a by a square plus x square. So this is the first differentiation of y with respect to x. See, if you want nth differentiation, so the nth differentiation of y is nothing but n minus 1 the differentiation of y1. So andre y1 andre first differentiation agide. nth differentiation ಬೇಕಂದ್ರೆ ಇನ್ನು ಎಷ್ಟು ಟೈಮ್ಸ್ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಮಾಡಬೇಕಿದು, ಇನ್ನು n minus 1 ಟೈಮ್ಸ್ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಮಾಡಬೇಕು. So it is nothing but n minus 1 the differentiation of a by a square plus x square. So we need to find n minus 1 the differentiation of this function. So let us take, this is some z is equal to, or let so take this expression is 1, no problem. Now you write this a by a square plus x square has a by a square plus x square can be written as x plus ia into x minus ia. I think you know the complex numbers. X plus ia into x minus ia is equal to x into, it is in the form of a plus b into a minus b, can be written as a square minus b square. A square is x square, b square is I square, a square. I square value is minus 1. If you substitute that here, x square minus of minus 1 into a square, so that is x square plus a square. So x square plus a square, or a square plus x square, can be written as x plus ia into x minus ia. So then its value is unaltered. So therefore this a by x minus ia into x plus ia, x minus ia into x plus ia can be written as, so it is a proper fraction, resolve this into partial fractions. It is x minus ia plus b by x plus ia. A by x minus ia plus b by x plus ia. So now a is equal to, so multiply throughout by x minus ia into x plus ia. So then a is equal to this capital A into x plus ia plus this capital B into x minus IA. So this is that step of what we followed in previous problems. So that is, you multiply this throughout by x minus IA into x plus IA. So then this denominator cancels here, x minus IA term cancels, remaining is x plus IA. In coefficient of B, x plus IA cancels, x minus IA remaining. Now to find the values, first you put x is equal to IA. Put x is equal to IA. If we take x is IA, then which implies that A is equal to this A into IA plus IA. So that is A is equal to 2IA into A. So which implies that in both the term, in both left and right hand side we have A, you can cancel this A. So remaining is 1 is equal to 2IA, which implies that A is equal to 1 by 2I. So remember that 1 by I means 1 by I can be written as minus I. 1 by I can be written as minus I. So you can write A as minus I by 2. So which implies that A is equal to minus I divided by 2. Similarly, to find B, put x is equal to minus IA. Put x is equal to minus IA, which implies that A is equal to minus IA plus IA cancels. So remaining here is, so it is A into minus IA plus IA plus B into minus IA minus IA. So this becomes 0. This is 0. So A is equal to minus 2IA into B. So in both the sides you can cancel A, which implies that B is equal to minus 1 by 2I. So you know that 1 by I can be written as minus I. So B values is equal to, the value of B is, which implies that B is equal to, so this is minus 1 by 2 into minus I. So that is plus I by 2. So therefore, now y can be written as y is equal to n minus 1th differentiation of n minus 1th differentiation of course it is lengthy problem. So this a by x a square plus x square can be written like this: a by x minus ia. A is minus I by 2. A is minus I by 2 by x minus ia plus b is plus I by 2 by x plus ia. Yes, now we need to apply the n minus 1th derivative for this. This is yn. So yn is equal to, in both the terms you can take minus I by 2 is a common factor. So that are plus I by 2 is a common factor. So here you take minus I by 2 into n minus 1th differentiation of 1 by x minus ia plus I by 2 into n minus 1th differentiation of 1 by x plus ia. As you remember this formula, nth differentiation of, you know this, nth differentiation of 1 by ax plus b is equal to minus 1 to the power n, into n factorial into a to the power n by ax plus b to the power n plus 1. Yes, by using the same formula here we have, so in place of ax it is x, in place of b we have minus ia. So use the same formula for n minus 1 the differentiation. So minus 1 to the power n minus 1 and n factorial becomes n minus 1 factorial, and similarly that a to the power of n becomes a to the power n minus 1, and ax plus b to the power n plus 1 becomes ax plus b to the power n. So here I am not applying nth differentiation, it is n minus 1th differentiation. So yn is equal to, so yn can be written as yn is equal to minus I by 2 into, this is minus 1 to the power n minus 1, n minus 1 factorial into a value is 1 to the power of n, it is not necessary to write that 1 to the power of n. This divided by x minus ia to the power n ತಗೊಳ್ತೇನೆ, ಯಾಕೆಂದರೆ ಇಲ್ಲಿರೋದು nth ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಲ್ಲ, n ಮೈನಸ್ 1th ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್, ಅಂದರೆ ಎಲ್ಲೆಲ್ಲಿ n ಇದೆ ಅಲ್ಲೆಲ್ಲ ಒಂದು n ಕಡಿಮೆ ಆಗಬೇಕು. ಸೊ ಕಡಿಮೆ ಆಗಬೇಕಂದ್ರೆ ಅಲ್ಲಿ ax plus b to the power n plus 1 ಇದೆ, here you write x minus ia to the power n. Similarly here plus I by 2 into minus 1 to the power n minus 1, n minus 1 factorial by x plus ia to the power n, x plus ia to the power n. Or you write this one as the final simplified value is yn is equal to, that is the nth differentiation of tan inverse of x by a, this is equal to, you take I by 2 common factor and minus 1 to the power n minus 1 into n minus 1 factorial is common factor. So then first you write the positive term. The positive term is 1 by x plus ia to the power n minus negative term is 1 by x minus ia to the power n. Okay. So this is the nth differentiation of tan inverse of x by a. So this is not our desired result. Actually show that ಅಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. So we have to show that it is minus 1 to the power n minus 1, n minus 1 factorial by r to the power n ಅಂತ ಹೇಳಿದ್ದಾರೆ. Okay. This is r to the power n minus 1 to the power n minus 1. So minus 1 to the power n minus 1 is there, n minus 1 factorial is there. So, but this is not our desired result. So for that you take one substitution, put x is equal to r cos theta, y is equal to r sin theta. X is equal to r cos theta, y is equal to r sin theta. Sorry, y is not there here. ಇಲ್ಲಿ y ಇಲ್ಲ ಇಲ್ಲಿ actually. So y is not there. So you take it as a, y ಅಲ್ಲ ಅದು a ಅಂತ ತಗೋಣ. Sorry, make it is a. Take that is a is equal to r sin theta. Now you take that x plus, okay, so then squaring and adding, x square plus a square is equal to r square cos square theta plus r square sin square theta. So then it is x square plus a square is equal to r square into cos square theta plus sin square theta. Sin square theta plus cos square theta is 1. So x square plus a square is equal to r square. ಯಾಕೆ ಇದು ಬರೀತಿದೀವಿ ಅಂದರೆ ಫೈನಲಿ ನಮಗೆ ರಿಸಲ್ಟ್ ಆನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಆರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಅವಾಗ ಆರ್ ವ್ಯಾಲ್ಯೂ ಏನಂತ ಹೇಳಬೇಕಲ್ಲ ನಾವು. ಸೊ ಆರ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎ ಸ್ಕ್ವೇರ್. Similarly you divide this one, so that is r sin theta divided by r cos theta. You see r sin theta is a, r cos theta is x. So this r and r cancel. Sin theta by cos theta is tan theta. Tan theta is equal to a by x. R theta is equal to tan inverse of a by x. Theta is equal to tan inverse of a by x. So we need to put all these values here. Yes, this is the expression 1. This is 1. So you take this is 2, take this is 2, put this into, put all these values into. So ಬೇಕಾದ್ರೆ ನಾವಿಲ್ಲಿ ಫಸ್ಟೇ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಣ ಏನು ಬರುತ್ತೆ ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ಎ ಏನು ಬರುತ್ತೆ ಅಂತ ಬೇಕಾದ್ರೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. ವಾಟ್ ಈಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ಎ? ಸೊ ವಾಟ್ ಈಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ಎ ನಾವು? So x plus ia is equal to x is what? R cos theta plus I into a is r sin theta, which is equal to, you take r common factor, it is cos theta plus I sin theta, which is equal to r into e power I theta. Similarly x minus ia is equal to ಏನು ಬರುತ್ತೆ ಅಂದರೆ x minus ia r into cos theta minus I sin theta ಬರುತ್ತೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು ಅಂದರೆ ಇದು ದಿಸ್ ಈಸ್ r into e power minus I theta ಆಯಿತು. ಸೊ ದೆನ್ ಇಫ್ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಇಯರ್, ಅದೆರಡು ತೊಗೊಂಡು ಬಂದು ಇಲ್ಲಿ ಹಾಕಿದ್ರೆ ವೈ ಎನ್ಗೆ, ಸೊ ನಾವು ವೈ ಎನ್ ಬಿಕಮ್ಸ್, ವೈ ಎನ್ ಏನಾಯ್ತು ಅಂದರೆ, ಸೊ ದಟ್ ಈಸ್ ವೈ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಐ ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಂಟು minus 1 to the n minus 1, n minus 1 factorial into n minus 1 factorial into, so 1 by x plus ia to the power n, so that is 1 divided by x plus ia is r into e power I theta, that to the power n minus that to the power n minus 1 by x minus ia to the power n, so that is minus 1 by r into e power minus I theta to the power n. Okay, simplifying this, yn is equal to I by 2 into minus 1 to the n minus 1, n minus 1 factorial into, you see this becomes r to the power of n into e power I n theta, so you can write it is 1 by r to the power of n into e power I theta to the power of n can be written as e power I n theta minus this, similarly this is 1 by r to the power of n into e power minus I n theta. So now which is equal to I into minus 1 to the n minus 1 factorial divided by 2 into, so in both the terms you can take r to the power of n common factor, and it is e power minus I n theta, because when it comes to numerator e power I n theta ಇದೆಯಲ್ಲ ಅದು ನ್ಯೂಮರೇಟ್ರಿಗೆ ಬಂದರೆ e ಪವರ್ ಮೈನಸ್ ಐ ಎನ್ ಥೀಟಾ ಆಗುತ್ತೆ, ಮೈನಸ್ ಇದು ಪ್ಲಸ್ ಇರೋದು ನ್ಯೂಮರೇಟ್ರಿಗೆ ಬಂದರೆ ಮೈನಸ್ ಇರೋದು ಪ್ಲಸ್ ಆಗುತ್ತೆ, ಪ್ಲಸ್ ಐ ಎನ್ ಥೀಟಾ. ಸೊ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು I into minus 1 to the n minus 1 factorial divided by 2 into r to the power of n into, you know that e to the power of I theta is cos theta plus I sin theta. Similarly, e to the power of minus I n theta can be written as cos n theta minus I sin n theta, minus e power plus I n theta is cos n theta minus I sin n theta. Actually ಇದು ಪ್ಲಸ್ ಬರುತ್ತೆ, ಮೈನಸ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ both becomes minus. So now plus cos n theta cancelled with minus cos n theta, so now this is equal to I into minus 1 to the n minus 1 into n minus 1 factorial divided by 2 into r to the power of n. Sum of these two terms gives that minus 2i sin n theta, minus 2i sin n theta. This 2 cancel with this 2. I into I is I square means minus 1, minus of minus becomes plus, so which is equal to minus 1 to the n minus 1 factorial factorial into sin n theta divided by r to the power of n, where r is equal to square root of x square plus a square, sorry, and theta is equal to tan inverse of theta is equal to tan inverse of a by x. Theta is equal to tan inverse of a by x. This is the nth differentiation of tan inverse of x by a. Yes, that same thing is given here. Huh? So minus 1 to the n minus 1 factorial by r to the power of n into sin n theta. So therefore, nth differentiation of, okay, write one more time, nth differentiation of tan inverse of x by a is equal to minus 1 to the power n minus 1 n minus 1 factorial divided by r to the power of n into sin n theta, where r is equal to square root of x square plus a square, theta is equal to tan inverse of a by x. Theta is equal to tan inverse of a by x. As in the given problem, so they are asking to find nth differentiation of and hence reduce anta kottidare, and hence reduce dn of tan inverse of x. So take this expression is 3, take this expression is 3. Okay, so it is very easy to find the nth differentiation of tan inverse of x, because in place of a, if you take 1, in place of a take 1, so then we can easily obtain the nth differentiation of tan inverse of x from the expression 3. So to find nth differentiation of tan inverse of x, put a is equal to 1 in result 3. Put a is equal to 1. If you put a is 1 here, a ge 1 kotre 3 nalle, so that is dn of, that is nth differentiation of tan inverse of x by 1 is x. This is equal to, in right hand side also we have to take a is equal to 1 minus 1 to the n minus 1 n minus 1 factorial, this does not alter, ಅಷ್ಟೇ ಇರುತ್ತೆ ಅದು, r to the power of n into sin n theta, that same result, where ಇಲ್ಲಿ change ಆಗುತ್ತೆ, where r is equal to square root of x square plus a square ಅಲ್ಲ 1 square, because a is 1, and theta is equal to tan inverse of, theta is equal to tan inverse of 1 by x, tan inverse of 1 by x. Yes, here you just make some changes here. So take this expression is 4. So now this is the result, this is the nth differentiation of tan inverse of x, no doubt in it, but we can make some changes here. So that is here you take theta is equal to, what you obtain, theta is equal to 1 by 1 tan inverse of 1 by x. So theta is equal to, here theta is equal to tan inverse of 1 by x. So what is tan theta? Tan theta is equal to 1 by x, or what is x? X is equal to 1 by tan theta, correct? So then x is equal to cot theta, x is equal to cot theta. So put this value in r, put this in r, and now r is equal to, what is r? R value is x square plus 1. So x is what? Cot theta. So cot square theta plus 1. R is cot square theta plus 1. So that is r is equal to square root of 1 plus cot square theta can be written as cosecant square theta. So r is equal to root and square cancels, r is equal to cosecant theta. So now equation 3 becomes equation 4. So 4 becomes, if you substitute the same here, so then dn of, now 4 is, now 4 becomes, expression 4 becomes nth differentiation of tan inverse of x is equal to minus 1 to the n minus 1 n minus 1 factorial by r is cosecant theta, that to the power n, cosecant theta to the power n. So cosecant theta to the power of n into sin n theta, which is equal to minus 1 to the n minus 1 n minus 1 factorial sin n theta into, you see cosecant 1 by cosecant theta can be written as sin theta. So when you bring this to numerator ಬಂದ್ಬಿಟ್ರೆ ಇದು 1 by cosecant ಇರೋದು sin ಆಗುತ್ತೆ, sin theta to the power of n ಆಗುತ್ತೆ. So you can write that is sin n theta, sin to the power n theta. So cosecant theta whole square ಅಂದ್ರೆ cosecant square theta, cosecant theta whole to the power n ಅಂದ್ರೆ cosecant to the n theta, like that. So 1 by cosecant to the n theta can be written as sin to the n theta. This is the nth differentiation of tan inverse of x. Suppose if they ask to find, ಈ ಥರದ್ದು ಏನಾದ್ರು ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದ್ರೆ, ಸಾರಿ evaluate ಹೀಗೆ evaluate nth differentiation of tan inverse of 2x by 1 minus x square. If they ask to find the nth differentiation of tan inverse of 2x by 1 minus x square, ಏನು ಮಾಡಬೇಕಿಲ್ಲಿ ಅಂದರೆ, so you take y is equal to, let y is equal to 2x by, sorry, tan inverse of 2x. This is tan inverse of 2x tan inverse of 2x by 1 minus x square. So now put x is equal to tan theta. So then y is equal to, it is tan inverse of 2 tan theta by 1 minus tan square theta. 2 tan theta by 1 minus tan square theta. 2 tan theta by 1 minus tan square theta can be written as, ಇದನ್ನು ಹೇಗೆ ಬರಿಬಹುದು ಅಂದ್ರೆ, this is tan 2 theta. Tan inverse tan cancel, y is equal to 2 theta. So y is equal to 2, what is theta? So theta is equal to tan inverse of x. Theta is tan inverse of x. So it is 2 into tan inverse of x. Now apply nth differentiation. So then yn is equal to 2 into nth differentiation of tan inverse of x. So that is 2 into, you know that nth differentiation of tan inverse of x is given here. It is minus 1 to the n minus 1 factorial sin n theta into sin to the power of n theta. So here theta is, what is theta here? Where theta is equal to tan inverse of 1 by x. Or you can write it is cot inverse of x. Cot inverse of x, you write the same thing. So it is minus 1 to the n minus 1 n minus 1 factorial into sin n theta into sin to the n theta. Sin n theta into sin to the power n theta, where theta is equal to cot inverse of x or tan inverse of 1 by x, or you write it is cot inverse of x. So like this, like that, you can solve this type of problem. Sine inverse of 2x by 1 plus x square is 1 plus x square is there. In that time also you take put x is equal to tan theta. That type of nth derivative problems you can solve easily. So next class I would like to discuss nth differentiation of. Suppose just think over it. This, if y is equal to some x to the power 5 into x to the power 5 into sin x is there. So then what is its nth derivative? What is the nth derivative of this product? So we know the nth derivative of sin x. We know the nth derivative of x to the power of n, x to the power of m. But if they are given the product of a polynomial and trigonometric, exponential and trigonometric. Exponential and trigonometric, we know that the standard formula is e to the power of ax into sin bx plus ಇದು formula ಇದೆ. So like that. ಸೊ ಈಗ ಪ್ರಾಡಕ್ಟ್ ಕೊಟ್ಟರೆ ಅದರ ಎಂಥ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ನ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು? ಇಸ್ ದಟ್ ಎನಿ ಅದರ್ ವೇಸ್ ಟು ಫೈಂಡ್? ಸೊ ಇಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ಇದ್ದಾಗ ಸಪ್ರೇಟ್ ಹಾಗೆ ಎಂಥ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ ಎಕ್ಸ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಮ್, ಎಂಥ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ ಸೈನ್ ಟು ದಿ ಸೈನ್ ಎಕ್ಸ್ ಹಾಗೆ ಬರೀಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಸೊ ದೇರ್ ಇಸ್ ಸಮ್ ರೂಲ್. ಪ್ರಾಡಕ್ಟ್ನ ಹಾಗೆ ಬರೋದಿಲ್ಲ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ. ಸೊ ಎಕ್ಸ್ ಟು ದಿ ಪವರ್ ಸೈನ್ ಎಕ್ಸ್ಗೆ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್, differentiation of x to the power 5, differentiation of sin x alla. So we are using some rule to find its differentiation. Like that, if you take its nth differentiation, so then what rule we need to follow that? So we discuss that in next class. With the help of some theorems, we can easily find its nth differentiation. So thank you.